Good morning, students. We are studying NCERT Class 8 Math Part 1. Today we will start the new chapter number 5, Numbers Play. Today is 19 August 2026. Till now, we have studied the previous 4 chapters. If you want to revise or you want to complete your previous chapters, you can follow the previous videos to complete those chapters. Today we will start with the new chapter, that is number play. We will see what is your first topic 5.1. Your 5.1 topic is this a multiple of, and both are left blank. Means what this statement says, that there is some number is given, and you have been asked to find out that this particular number is a multiple of, there is also some number will be given to you, and you have to just confirm that this number is a multiple of this number or not. Understood? We can take an example. See, if we have written 8 here and the statement is 8 is a multiple of, we can write here any number. Suppose we have taken 2. Now if I say 8 is a multiple of 2 or not, then you will say yes, 8 is a multiple of 2, because when you see the table of 2, 2 fours are 8, that comes, and you can say, yeah, of course 8 is a multiple of 2. And also what if you write here 4, then you can conclude that yes, of course 8 is a multiple of 4. And if you write here 8, of course you can say 8 is a multiple of 8. And you can also write here 1. What does that mean? That 8 is a multiple of 1. Now, so your chapter start with this topic, that some unknown number is, or some fixed, we cannot say it an unknown number. A number given to you is a multiple of the given number or not. How you will identify that, we will see. So see, there are infinite numbers, to find out that the infinite numbers are multiple of some infinite numbers is impossible. So particular we will see some particular numbers, and we will try to find out their multiples. Now see, the most commonly used number which come in our mathematical operation, and we have to find out whether the given number is multiple of that or not. They are, say, 1, you can easily find out, 2, 3, 4, 5, 6, 7, 8, 9. Understood? And if we continue this list, 10, 11, 12. Now see, if you are able to know up to 12, that if you are certain that the particular any number is given, and if you can identify just looking at that number, that the particular number is multiple of any of these numbers, you can find out the you can find out that you should know, actually you should know how to find out the multiple of these numbers. If any number is given, you should know how to certain that this number is multiple of these numbers. Other than these numbers, you will say few numbers are there, like 13, 17, understood, 21, 23. So what are these numbers? Actually these numbers are prime numbers. So once you are certain that till 12 nothing is the number is not divisible by any particular number, then you have to guess that the particular number is a multiple of maybe a prime number, and which prime number, that you have to check with the country method or the sure and short method, that you have to divide that number with these prime numbers. Then you will certain that yes, the particular number is a multiple of which number. Now, how to find out that any number is a multiple of 2, any number is a multiple of 3, any number is a multiple of 4, any number is a multiple of 5, 6, 7, 8, 9, 10, 11, 12. There is some method that we will see in this chapter. The complete chapter is about this, that how you will identify the particular number is a multiple of these numbers, and we will see. The particular term used is the divisibility rule. Means what are the divisibility rule of these numbers, that we will see. Now, so actually I was explaining the concept of this statement which is given in your starting of this chapter 5.1. Is this a multiple of? In your book it is written like this. So like this, and I have explained what is the meaning of this statement. And now we will go with the chapter, how the chapter moves. We will go with the flow of the chapter. Understood? We will discuss the few things which are given in your chapter. Then what conclusion comes of our discussion, that we will see, and that conclusion will be a divisibility rule of a particular number which we have discussed here. So the first thing what they have said in our book is that what they are saying, that we have to see the sum of consecutive numbers. Sum of consecutive numbers. Now they have given the example like that. Can 7 be represented as a sum of any consecutive number? You find out that 7 is the sum of consecutive number 3 plus 4. Understood? Likewise, they have given some more examples that we'll see. They have given 10, 12 and 15. And what is about 10? 10 is a multiple of any consecutive number, that we will see. Now we have to seek the consecutive number. Now 1 plus 2 plus 3 plus 4. We see that these are consecutive number and the sum is 10. What another example they have given? They have given the 12 and 15. What about 12? The 12 is consecutive number 3 plus 4 plus 5. Understood? And then they have given 15. What about 15? Is 7 plus 8. Also, they have breakdown of it to 4 plus 5 plus 6. And also, they have breakdown it as 1 plus 2 plus 3 plus 4 plus 5. Now see, this is already given your chapter which I have copied here. What I want to explain you, I want to go, I want you to pass through this journey. At the end of our discussion of this topic, we'll come to a conclusion. Understood? And I can explain you that conclusion directly. But the chapter required you to pass through a journey which I am helping you to pass through that journey to reach to that conclusion. Now see, we have represented 7 as a sum of two consecutive number, that is 3 and 4. What we have observed that this continuation is not started from 1. Understood? In case of 10, we have started from 1, 2, 3, 4. So this is not certain that what will be your starting number. I mean, your 1 is not always the starting number. Only you have to find out the consecutive numbers, and which the sum is 10. Understood? So in case of 12, what we have seen, 3 plus 4 plus 5. And in case of 15, what we have seen, that we have three options. The three options as a consecutive number, that 7 plus 8 are consecutive and the sum is 15, and 4 plus 5 plus 6 are consecutive and the sum is 15, and 1 plus 2 plus 3 plus 4 plus 5 are consecutive number and sum is 15. Understood? So the conclusion is that of this discussion, that you can have different set of consecutive numbers also to obtain the same sum. Understood? From this discussion only you can conclude that there may be more than one way of finding the consecutive numbers, set of consecutive numbers to have a equal sum. Now we'll see what is next. Now see what they are asking, that can we write every natural number as a sum of consecutive number? Is it possible that any natural number can be represented as a sum of consecutive number? Now see, for this discussion we can see that if we have any odd number, means if we have any odd number, suppose we have taken 5, 11, any odd number, now we can see that 5 plus 6 are consecutive and their sum is 11. Understood? Or we have find out, just reduce 1 and half of the number, half it, you will find out the uh, consecutive number. In the same way, any odd number like this is 21, and you can find out that 20, 21 minus 1 is 20, and half of 20 is 10. So your one number is 10 and other number is 11, and you will get the result 21. In this way you can see that all the odd numbers can be represented by a sum of consecutive numbers. And not only this way, we have different ways also. The possible way are different, but this is the certain way that any odd number can be represented by a sum of consecutive numbers. Now we will see the case of even number. Is it possible in case of even number that all the even numbers can be represented by a sum of? Is it possible? Now see, if we take 10, we have seen that 10 can be represented by the sum of consecutive number, that is 1 plus 2 plus 3 plus 4 plus 5. Understood? But is there any short and is there any certain way? Now, if we split it, say 4 plus 6. Understood? What is in between them? 5. And this 4 is 1 plus 3. Then what is left? 4. Now, what we are struggling here? We are struggling here to find out a pattern through which we can find out the. We are struggling here to find out a pattern through which we can find out the consecutive numbers. We can through which we can find out that the even number can be represented by a sum of consecutive number or not. That we are struggling here, but in case of odd number we are very certain. Understood? Now there is no certain pattern to find out that these are the consecutive numbers that have the sum 10, but in case of odd number you can find out this. This you can find out by your hit and trial method. Now what is the second point of discussion? That which numbers can we write as a sum of consecutive numbers in more than one way. This is also not certain that which numbers can we write at more than a sum of more than one way. That even we can write even numbers and odd numbers as a sum of more than one way. Now, yes, of course, they are saying that, yes, oh, I know all the odd numbers can be written as a sum of two consecutive numbers. Can we write all the even number as a sum of consecutive numbers? This is what our discussion. That we find difficulty because we don't have a certain pattern to find out the sum of consecutive numbers to get the sum or as a even number. Now, they are saying that can we represent 0 as a sum of consecutive number? Of course, 0 can. How can we say that 0 is a sum of consecutive number? Now see, if we take -1 plus 0, you get the result -1. And if we take -2 plus -1, we will have a result -3. Means it is not possible to get the result 0 by adding two consecutive numbers. You will always sum different result other than 0. Now they are saying that we have to explore these by taking the different numbers also. Now what they are saying, they have given us the 4-digit numbers, and they have given us 4 different numbers, and we have to apply different operations between them, and we have to see the pattern in the result. This is next part of our discussion. They have given us 4 number, 3, 4, 5 and 6, and we have to apply the mathematical operation addition and subtraction between them to get the result. Now in first way they have applied addition, then in this way they have completed. Then how many times? Actually this is 8 times. They have drawn a tree, but we will write each and every combination. So these are all the possible combinations with these 4 different numbers, and let's see the result. What is the result? What is the result? This is 18. Now what in this case? 6. And what in this case? This is the result of this case, and this is the result of this case, and what is in this case? -10, and in this case -2, -0, and what is in this case? -12. So what we have, this is the only possible combination of mathematical operation addition and subtraction we can put between these 4 different numbers, and we get the result we got the result that all the result is even. All these numbers are even. Understood? All these numbers are even. See, 0 is considered as even, when something is placed before it. Understood? Means 2, 3, 4, 5, any number you will place, that number will become even. That's why we are considering it as even. So we see that in when you have given any four different number, different number, and you apply any type of combination between them, you will get the result even. And you can, we have taken these numbers 3, 4, 5, 3, 4, 5, 6, and you can take any different number for your trial, and you will find out that whether the number is negative, positive, but the result will be even. This is the pattern we have seen here. Now what this pattern concludes? Thus this pattern occurs no matter which four consecutive numbers are chosen. Is there way? Yes. Now if we take these numbers as a journal number, and they have given us a we will see the what the results come, then we will reach to the final conclusion. What they have said, suppose we have taken any four number A, B, C and D. Now place any mathematical operations between them, say we have placed this. Understood? Now what will be the result of this number? Suppose we change any operations. This is one number, and the second number is obtained by changing one operation, A plus B plus C minus D. Understood? This is our another number. Now we subtract this number from this number, and we will see what the result comes. A plus B minus C minus D. We'll do the subtraction. A plus B plus C minus D. And after opening the bracket, what result we will get? Minus A minus B minus C plus D. What do we say? Plus A and minus A will be cancelled out. Plus B and minus B will be cancelled out. Minus D and plus D will be cancelled out. What will be our result left? Minus C and minus C, that is 2 minus C. This is our result, and this is a even number. This is a even number. This is our conclusion, which we have concluded by taking the example of 3, 4, 5 and 6. Now this is the general conclusion, that the result is always even number, and we will see it with one more example. We will see it one more example. Now see, okay, we will change this, or we will make it D. Now this is the combination. Now we subtract this number from this number. We'll see what is the result. Now A plus B minus C minus D minus A plus B plus C plus D. When you open the bracket, you will get the result A plus B minus C minus D minus A minus B minus C and minus D. What numbers are cancelled out? A, B. Understood? Now what is not cancelled out? Minus C, 2 minus C and 2 minus D. If we take minus 2 outside, we will get C plus D. Now, any number when you multiply it with 2, the result is even. That may be a negative, that may be a positive, but the result is definitely a even. So, what we have concluded that if we place any operation between them of addition and subtraction, we will get the result always even number. Understood? This is we have seen with the variables also, that is the generalized form. So this is the conclusion of our discussion for this particular topic. And what is the conclusion? The conclusion is that, now see, we know that addition of odd and subtraction of odd is always even. Understood? Addition and subtraction of odd is always even, and addition of even and subtraction of even is always even. This you can prove. Understood? But addition of odd with even is always odd. Remember this point. Whenever you add or subtract an odd and even number, you will get always as result odd. And when you will add odd number with odd number, you will add subtract odd number with odd number, you will get the result even. Same in case of even. When you add two even number, you will get the result even. When you subtract the two even number, you will get the result even. But when you subtract or add the odd and even number, you will get the result odd. That we will see. What is the result of four numbers? That odd plus minus odd plus minus odd plus minus odd. Your result will be even. You know, this result will come as even. This result will come as even, and their combination is also even. Understood? Now, if we see, if we write, now what are the possible combination of these four? What are the possible combination of these four? We will see. There are 8 possible combinations. Understood? 8 possible combinations. Now see, even, 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 even. Your result will be even. Understood? Now, see, you have a combination of even, odd, even, odd. Now what will be your result? You say, you see that this combination will come as odd and this combination will come as odd, and the odd of two number is even. So what is the conclusion? That in case of four numbers, now this is our final conclusion. In case of four different numbers, whether they are odd, whether they are even, and any mathematical operations of addition and subtraction is applied on them, you will get the result even always. You will get the result even always. This is the conclusion of our discussion for today's class. I will repeat again, any four numbers, whether they are odd or whether they are even, and you are applying the mathematical operation of addition and subtraction in any combination between them, you will always get the result even. Understood? And this even means, what does this even means? This even means this is a multiple of some number. This is a multiple of some number 2. So this is all about the discussion of today's class, students. We will discuss the further part of this chapter in next class, and we will, in the next class, we will come to the conclusion and we will see the divisibility rule of 2. Understood? Why I am explaining all these things to you in step by step manner, so that you have a sense that how we have concluded to the how we come to the conclusion that the divisibility rule of 2 is what, and we should not directly learn what is the divisibility rule of 2. We should come to that conclusion, so that it will retain in our mind and we understand the depth concept that what is the divisibility rule of 2. In the same manner, we will see the divisibility rule of other numbers also, which is given in your chapter. Understood? That's why we have discussed each and every points which are mentioned in your chapter step by step, and we will do the discussion of this chapter in further classes. Till then, take care and thank you very much.